Hi folks, I'm Ron Brown. Welcome to my shop. Steady rests have been around a long time, mainly because they solve so many problems that otherwise are a little bit tricky to deal with. For example, let's say you're turning something long and thin. Now this is just a piece of scrap I had to illustrate the point, but I think you can probably see how flexible it is. And when I tried to rough it down here a few minutes ago, I didn't get very far. So steady rests come in lots of varieties and sizes and shapes. The ones I want to talk to you about today are for doing very small diameter work. When I say very small, from 1/8 of an inch up to about 2 inches. And this is a steady that's been around for a long time, but I've totally redesigned it. Why? Well, most of us, a lot of us, have more than one lathe, or we start out on a smaller lathe and we go to a bigger lathe. The line that I have developed will take care of any lathe from 10 inches all the way up to 25 inches. Let me show you what I mean. Well, as you can see, a lot of chatter, not great concentricity here, kind of gave me a false middle. People use steady rests to steady a turning which is real whippy or wobbly or something that's bendy in the middle. For example, this is an actual wooden golf club handle made out of hickory. A few years ago, I turned 800 of these for a customer who was putting on a vintage golf tournament. And hickory doesn't break easily, but boy is it springy. That's why they use it for these kind of handles and hammer handles and that sort of thing. So on this one, I actually used 2 steadies. But let's say you've got to turn stair rail balusters, for example. Those could be small like this in the middle, and they're going to get really whippy. You might be turning Harry Potter wands. For example, crochet hooks, knitting hooks. Maybe if you're a weaver, you're turning drop spindles and that sort of thing. One of the things that I love to use a steady rest for is if I do make a lot of my own tool handles, and when you're drilling this end, a lot of times the drill will wander off and you'll end up with a tool handle where your gouge is not straight. Let me introduce this new line of mini steady rests from RonBrown'sBest. The smaller one here will take care of any lathe from 10 inches to 14. So it fits a 10-inch lathe, a 12, a 12.5, or a 14-inch lathe. The next one here fits lathes from 16 inches to 20. So 16, 18, and 20 will be taken care of by this size. If you have one of the bigger lathes, the Lagunas or the one-ways or even one of the big Powermatics, this particular one will fit lathes from 24 to 25 inches. It actually will go up to 26 inches. That's the line that we're introducing right now. Let me show you how it works. This is a 16-inch lathe. I'm going to install the 16-inch steady on here and show you how it works. Installation is very easy. You do need a flat spot, something that's round, for the ball bearings to run on here. So you can't just put something square in it, not going to work. So it's open on one side. That means that you can just put it over your workpiece. And this is the clamping plate. I designed this with something special in mind for you. You know how if you want to find the center of the board, you can get the device that has a pin here and a pin here, and then with the pencil in the middle, you run it down and it's perfectly centered. Well, I've adapted that technology to our clamping plate here. So when you twist it and this side makes contact and this side makes contact, your steady rest is going to be exactly centered in the middle of your workpiece. So I've installed the clamping plate on the bottom, turned it clockwise. It's now perfectly centered in the middle of my bedways. Each one of the bearings, now we just gently want them to make contact with our workpiece. We're going to start the lathe up slowly. You always want to double check everything's making contact, and that all of the bearings are turning, which they are. So this is now providing the same support that the chuck is or that the tailstock is. So right here in the center, I can crank the lathe up and I should have much less flex and be able to get a good center running point. Although the design is pretty simple, it does some pretty fantastic things. Let me show you what I mean. The design for all three sizes has a lot of things in common. For example, if you look at the 16-inch here bolts directly to the aluminum extruded base because it's exactly 8 inches from the lathe bed to the center. For an 18 or a 20, there is a riser block, and the C-arm would mount to the riser block, and it gives you a range of motion. So for example, the smaller one here right now is set up for a 12-inch lathe. If I were going to do a 10, I would actually remove the riser block and bolt the C-arm directly to the base like I've done with the 16. If I had, let's say, a 14-inch lathe, then we would just extend it so that it's now 7 inches from the lathe bed to the exact center of the spindle center here. If I had a 12.5, then I'd adjust it where it's 6 1/4 inches. So they're very adjustable, and I carried that design feature over through all three of them. So on the 16, if I wanted to use it on an 18 or a 20, the riser block would be installed, and I would just move it till I get the center, the spindle center, to the height that the lathe needs. The exact same thing happens here on the 24 and the 25. The way it's set up with the riser block, it's set for a 24-inch lathe. You move it up a 1/2 inch, now you're set for a 25. If you move it all the way up, it would actually be centered for a 26-inch lathe. There are three differences in the line. One is the size of the clamping block. On the bigger lathes with the much wider ways, you need the larger one. On a 10 or a 12-inch lathe, you need the smaller one. This is sized perfectly for the 16-inch lathe. The other differences are the length of the C-arm. This obviously is the smaller one. This is the 16 to the 20, and then this is the 24 to 25. So we have a difference there. The other difference is the size of the mounting plate. As you can see, the little one here is 6 inches, and the larger ones are 8. So those are the main differences between the three sizes. Let me ask you a question. What if you make the investment for your 10 or 12-inch lathe for the spindle steady and you really love it, and then one day you decide that you'd like to step up and you get maybe a 16-inch lathe? Well, this isn't going to work. So rather than have to reinvest and buy an entirely new setup, I have made a an upgrade kit. And the upgrade kit to go from a 12 to a 16 is 3 pieces. You have the 16-inch C-arm, you have the wider base plate, and you have the larger clamp bar. What a deal. So now you, in essence, have these two at a fraction of the cost of buying another whole unit. What about the other way around? What if you decide that you want to try a 16? And but you actually have a 16 already. You also have a 12, and either your wife uses the 12, or maybe the grandkids, or maybe you just love to turn certain items on the smaller lathe, and you'd really like to be able to use your steady, your 16-inch, on a smaller lathe. Well, we've done the same thing in reverse. In other words, you could get the smaller C-arm, the smaller clamp, and the shorter base piece. So now, even if you have this one for a fraction of what a whole unit would cost, you essentially have both of them. So it doesn't matter which way you start. And yes, we do the same thing for the larger lathes also. I want you to know that everything is CNC machined out of high-density polyethylene, HDPE. It's a product that I use extensively in various things that I make because it's so cotton-picking durable, and everybody just seems to love it. So we've used half-inch thick, high-density polyethylene. The ball bearings here are double sealed, and they're ABEC 9s. The only higher grade is a 10, and you just don't need, the 9 is actually, the 9 quality is actually overkill for what we're doing here. The aluminum extrusion is very durable, very, very strong. This should be something that you just buy once, and you use it no matter how big a lathe you get, or where you go, or if you downsize, you should be able to use this entire system. I'm Ron Brown. Thanks for watching. And remember, wherever you go, there you are.